Good day, everyone. I hope you've all been enjoying the 2023 Uni CTF so far. My name is Ziad. I am part of the Hack the Box Academy team, and today I'll be talking about advanced command injection. The content I will be covering is part of the Intro to Whitebox Pen Testing module, which is part of our recently announced Senior Web Penetration Tester job role path. Now, I will start at almost the end of the module. So, in this module, we cover the Whitebox pen testing process that we use within Hack the Box Academy and that we teach so you can use in your future web application pen testing. And so far we have already reviewed the code, the first step. We have done our local debugging and we have identified a code injection vulnerability. And now we are currently in the proof of concept step. If we see what we have achieved so far, we have identified, like I said, an advanced code injection vulnerability. So we are able to execute JavaScript code. And we have also been able to turn that into a command execution. So we use the execsenc JavaScript function, and we were able to execute commands. So if we have already reached command execution, doesn't that mean that we have achieved everything we wanted? Not exactly, because we haven't been able to retrieve the output of the commands that we have been executing. Let me show you why. Now, in general, there are multiple ways to retrieve the output of any command we carry through RCE, remote command execution. And the most common way is obviously just trying to get a reverse shell. However, in this case, our instance does not allow any outgoing connections, so we cannot just receive a reverse shell. Sometimes we use HTTP exfiltration, which is mostly used with XSS when you send a GET parameter with base64 encoded content, and we can just decode the command output this way. But as I said, the instance does not allow any outgoing connections, and it doesn't even have internet connection, so we cannot use the third way, which is DNS or ping exfiltration. We cover this in some modules in Hack the Box Academy, some of the web modules also in the job role path, and the Senior Web Penetration Tester job role path. And this way, this technique does not even work here because there is no internet connection. Sometimes, if the web application has a database, which is quite common, we try to store the output of the command. Since we have code injection, we can use database queries and store the output of the command somewhere in the database and then try to access it, somewhere like a page that we can access that would load some DB content. But the web application that we are testing does not actually rely on a database. So this option is not usable as well. The fifth way is trying to write the output of the command to a file and then access that file. Many web applications would have public directories that any file within them can be accessed publicly, like the CSS directory or the JS directory that includes JavaScript functions necessary for front-end web applications to work. And then we could just drop something there and access it that way. Unfortunately, the web application that we use does not have any public directories, and it only supports predefined routes that are linked to certain functions. Next, we could try to inject the output into the HTTP response and just send the injection request and retrieve the output in the HTTP response. And this would seem to be the easiest way because we would just send a request and then receive the output. We actually do show this way in the previous section where we manipulate the JavaScript code to change the HTTP response and inject the output of the command into the message. But the current section that we are in assumes that this is not even possible because in many ways you may not be able to actually inject the output of the command into the HTTP response. So what other options do we have? To be honest, we don't have many other options. The last option that we have is something that is quite often used with blind SQL injections, which is the time/Boolean-based exfiltration. So let's see if this last option is possible. Now, the time-based exfiltration has been thoroughly covered in the blind SQL injection module, which is also part of the Senior Web Penetration Tester job role path. But let's take a quick refresher. Basically, we say, check the first character of the output. If it is A, then sleep for 2 seconds. If not, skip. And then we would use the entire ASCII char set, all 100 letters or characters in it, and we would try them one by one until it sleeps for 2 seconds. Then we would know that the first character in the command output is actually A or B or whatever. Then we would go to the next letter and so on. Boolean-based exfiltration, on the other hand, is we try to change something in the response or in the page that gets rendered, so we would know that we have hit the correct character. For example, if it is a hit character, we match a character, then we send a 200 OK. Otherwise, we send a 403 response. Now, like I said, in the previous section, we assumed that this was possible. We can actually manipulate the HTTP response. But in this case, we are going with a situation where this is not possible. So the only option we have is time-based exfiltration. Okay, so the first thing we need to confirm is whether we can delay the response. If this is possible, then we can use this technique. Otherwise, we may not be able to use it. So if we go to our web application, like I said, we have already skipped many sections. So we are at a point where we can execute commands. And I can execute any command here, but I would not be able to get any response. For example, if I say ls, we just get could not generate QR code and we do not get any response. So let's see if we can sleep. We could use JavaScript code since we have JavaScript code injection to cause the delay using a function like setTimeout. But since we have already reached command execution, we can just use a bash command like sleep, for example, and we say sleep2 and we send the request, and as we can see, there's a delay. Whereas earlier when we said ls, it just responded immediately. We can try once again the sleep2 command, and we can see it takes about 2 seconds. We could check how long it took by going to the info section, and we see that it took about 2000 milliseconds, which is about 2 seconds. We can change it to 1 just to confirm that it is exactly the same, and yeah, we do get 1000. So we are able to cause a delay. And the reason is because we are using the JavaScript exec_sync function, which executes the function or the line of code synchronously. So if there's a delay, then it would wait for that delay. If it was an async function, an asynchronous function, then we would not be able to wait or delay the response. And that's why using JavaScript code like setTimeout may not be ideal in this case. So now that we are able to delay the response, what's the next step? We need to find a one-line bash command that executes a specific command like ls or cat flag or whatever, reads the first character in the output, compares it to a specific character that we set like A or B or C. If it matches, then we want it to sleep for 2 seconds. If it doesn't, do nothing, and we would send another request with a different character to check. This only requires basic bash knowledge to write, but we can just copy it, and we can use GitHub Copilot to generate this for us. Let's just tell it we need and let's see what it says. Excellent, it has provided a very short command, so we can just copy it and we can use it here. Now, we may need to escape the double quotes because we are using JSON, and JSON wraps the text into double quotes, so we can just escape those, and we will have the command where we can execute commands. Obviously, instead of your command, we would say something like ls. At this point, we are doing local testing because we are doing a white box penetration testing exercise, and we are trying to develop the exploit locally before firing it on the real target. So we should be able to know the output of the ls command so we can confirm whether it does actually delay the request or not. So we can just open the console, write ls, and we see this is the output, and the first character is n. So if we say if the first character is equal to n, then sleep, and we say that it does sleep. If it was equal to something else, a for example, it doesn't sleep. It responds immediately. So we can use this way to exfiltrate any command outputs that we want. Now we know that the first character is n. What about the second character and the third and the fourth? If we do head-c2, then this would actually take the first 2 characters and it would not match. We can obviously just append it here, like if we do n and then o. Let's see if it matches, and yeah, it does match. So this is one way to do it. Another way to do it is to do this, and then always take the final character, tail-c1, and then this would always be the final character. So in this case, it would be the second and then the third. So we can say, is the second O? And it is. Is it D? No. Is the third one D? Yes. So we can see that we have been able to find the first, second, and third characters, N, O, D, and so on. We can just repeat that. For every single character, we have to go through the entire ASCII card set and then move to the next character once we find it. Now, obviously, we cannot keep doing that manually because now we assumed that we know the first character to be N, and we were able to confirm that this technique works. But how can we actually fire it on a real target that we don't know the commands? We cannot do it manually because we do not want to go through the entire ASCII characters one by one. It'll take us like 1,000 requests and it'll take forever. So for such cases, we must write an exploit to automate all of this, which is our next and final step. Now, the final section in the module actually covers how to write a similar exploit. And I don't want to give anything away or show any spoilers, so let's assume that we have the script already written and we can try and see how it would look like if it was automated. We can go back and open the script, and we have it right here. Yep. Python 3, and open it. Now it says, which command do you want? We can just try ls, and we can see it's going through the entire characters. It found one, n, and then it goes to the next one, O, goes to the next one, D, and so on. Now, we are testing it locally, so it is very fast, but if it was on the real target, it would be a little bit slower. Something to keep in mind is that for such cases, we use a sleep delay that is not very long because we don't want it to take like 10 seconds whenever we hit a match. However, if we use the very short delay, like 1 second or 0.5 seconds, then it may not give accurate results because there are many things that may delay an HTTP response, and the response may take half a second or a second, and then we would hit a mismatch and we would actually not get accurate results. So we always recommend setting at least 2 or 3 seconds. But as we can see, it has been able to find the first word of the output. Now this has been scripted in this way, so it doesn't show any spoilers, but as a POC, we can see how this thing would work. In the blind SQL injection module, we actually show other techniques to make this more efficient and more optimized. And instead of going through the entire car set, we show 2 techniques of how to we optimize this and not go through the entire character set. And it will take up to 50 to 70% less time to show the command output. So this has been a quick look at advanced command injection and a technique that we can use with blind SQL injection, blind command injection, blind command execution, blind code injection. This technique we can use with many web vulnerabilities, but once we are able to understand it and are able to actually script it, then we can just modify our script slightly and just fire it at a different target with a different payload. So it's very interesting to learn. I hope you've all enjoyed this talk, and I will see you next time.